So how could it be that we still are explaining 93% of the variation in y? Well, let's suppose that we take two of them. Let's use income and the interest rate, and we'll run the income variable there, and we'll run the y variable there, and we'll plot this year's savings in the vertical. And so that we have S doesn't lie in the column space spanned by the independent variables. If in this multidimensional space, so the floor is the column space spanned by y and I. Suppose the vector S rises very steeply out of the corner. S hat is a point on the floor. So how close S hat is to S is going to determine r squared. Well, if S is rising very steeply out of the floor, the r squared is going to be very low. The angle between the floor and the vector S is quite large, and so the r squared is going to be small. On the other hand, if the vector S has a very small angle, it's very shallow, you know, the end of the vector S is right here instead of being up there. It's down here. So the error that we make is quite small. The r squared is going to be high. The angle between the vector S and the floor is going to be small, and therefore the r squared is going to be high. Okay? So the moral of the story is that apparently the vectors S lag, y, and I lie very close to one another, but S lies very close to the group of 3. That's why you got the r squared of 0.93. As a little experiment to help you understand why the group of 3 isn't helping us very much, or we can't distinguish between them, take your pencil and put it across your two outstretched fingers underneath it, so it's balanced on your two fingers, like that. Okay, so you got a pencil laying across your two fingers. The pencil is pretty stable. If you imagine your fingers are two basis vectors, because they're out at the ends of the pencil is a hyperplane. It's a very stable hyperplane. It's not very tippy. What happens when you move your two fingers to the middle? All of a sudden, the hyperplane that's balancing on those two basis vectors is pretty tippy, pretty unstable. And so we can't tell which finger is doing the work. There isn't a critical role for either one of them, although the two of them are still holding the pencil from falling. Okay? But when you move the angle between them apart, the hyperplane, which is your pencil, isn't tippy at all, and you can see that they're both doing some work. Okay? Yeah. So when your two fingers are close to one another, we can't say which finger is holding up the pencil, but we know that one of them is. You can't apportion the work being done to each finger. So when you move the fingers apart, they're the basis vectors. Now they're both working. And we can say, yeah, they're both working, because if we take one away, the pencil falls. Here, when they're both together like that, if we could squish our fingers, if our fingers were like two lines, they have length but no width. If we put our fingers together like two lines, we could take one of them away and the pencil wouldn't go anywhere. But when they're like that, we need both fingers to hold up the hyperplane. Okay. Estimate by least squares, rounded, what's the percent of coefficient? None. What's the short run marginal propensity to save out of income? What'd you get for that? None. Shit. What was the question I asked you? I gotta remember where I was now. Whatever it was, you answered it right. Opposed. What do you get for the marginal propensity to save, the short run marginal propensity to save? Let me put it differently. Which was bigger, the short run or the long run propensity to save? What did you show me? Which one was bigger? Which one? Oh, you came and showed me something. Which one is bigger? Who votes? What color is your shirt? No. Which one did you get? You didn't have a copy for yourself. The short run was bigger? Oh, you don't remember? I don't know. I haven't done it yet. So it's, was the number that you got for D bigger than the number you got for E? Yeah? So in the short run, people save more out of income than they do in the long run? Okay. Good. I don't know. Very good. Okay, any questions about the homework that you did for today then? I don't know, I haven't written it yet. This is one of my jobs for this week, is to write exams for you guys and one for my other class.
Also, a lot of the problems we get like on a dog, we're not going to be able to do that.
You think I'm going to give you
Something.
4 variables with 30 data points in each one and tell you to run a regression there at your desk with just a pencil and paper?
That'd be the only question.
That would be cruel and unusual punishment. Not a bad idea, but...
No.
Yes. Alex.
I don't know how you do it.
E and E? No.
Because what I did was,
Hang on, let's open it again. We discussed that last week. Didn't we? Here you have an equation which says that savings today depends on savings yesterday. If the economy is unchanging, how would you characterize that? What adjective would you characterize the economy? Things are unchanging. Steady state, right? So if things are unchanging, the household has stopped making adjustments to short-term changes, then what must be true about savings today and savings yesterday? It would be the same. Okay? So if you have, if ST minus 1 is equal to ST, what should you do with ST minus 1? Take it over to the left-hand side. You can't have the same thing on both sides of the equal sign, can you? Doesn't make any sense. No. So on the left-hand side, you then have 1 minus B times S. And you only want S on the left-hand side, so divide back through 1 minus B. For the short-term, marginal propensity to save would be C. And the long-term would be C over 1 minus B. C, of course, should be a number less than 1. Well, I guess it's arguable what you could do in the short run and the long run. Propensity to save. Right? Depending on what number you got for B, you might get it bigger or smaller. Okay. Anybody else? No?
So you said short run was
C.
Just the parameter for
Just C.
savings. Okay.
And the long run was C over 1 minus B.
where does C come from?
You had an estimate of C. That's why I had you fit the equation. You got estimates of both C and D, right? What's the derivative of S with respect to Y in the short run? Just C. What's the derivative of S with respect to Y in the steady state? C over 1 minus